Okay, I'm back. We have finished step one of this transformation. Specifically, we have added a store, an immutable store, and we have passed it to every function that we think might need it, but we are not yet using it in any way. In order to illustrate how we're going to use it, I'm going to focus, as I did before, on the innermost function, this vector swap, and we're going to see how to handle this. And after we get that one working, then we are going to try to bring everything else back into the picture. So, the first question is, how will we represent vectors using our store? The idea is that since our store maps numbers to numbers, that a vector can be represented as a range within that store, essentially as a pointer into memory and a length. We're going to define a new type for this. A muvec, a mutable vector, represents a mutable vector. Define type muvec. It's going to be essentially a single structure that contains a pointer, which is a number, and a length, which is a number. So now we can represent vectors as being pointers into the store. Let's take a concrete example here. Example of vector. Okay, using in the old style, we would have written vector 3, 4, 12. Okay, that would have been a vector containing the elements 3 and 4 and 12. But we're now going to try to represent that using our new system. Right? And now what we're going to say simply is that this vector might be represented as muvec pointer to a memory location. Oh no, where does this thing live in memory? Well, it almost doesn't even matter. Let's say it's at location 237 and it's of length 3. Okay. How are we going to specify the actual elements in the vector? Well, those now appear in the store. That is to say, we need to also have a store that contains the actual values. So in this case, we might have a hash list values, and location 237 would contain the first value in the vector, 3, and location 238 would contain the next one, which is 4, and location 239 would contain the last one, which is 12. So in other words, in order to represent this vector here, we now need two things. This piece, the muvec, which contains the pointer and the length, and the actual store. Okay, so we're breaking it up into two pieces. This is going to represent the value, and this is going to represent the store, which is basically getting passed around everywhere. So what do we do next? What we'd like to do is to try out our new representation, and in order to do that, we probably want to take a look at vector swap. So our vector swap operation, let's say that before we had called vec swap with this vector, and we said swap elements 1 and, well, let's say 0 and 1. The result should have been vector 4 and 3 and 12. All right, that's how the old vector swap worked. So what we're going to do now is to go to the new kind of vector swap, and this one should work as follows. If we call vec swap with this vector, and we're going to swap, again, locations 0 and 1, in the presence of this store, what should be the result of this thing? Well, the vector itself does not change. The muvec value is still a pointer to location 237 and still of length 3. The difference is going to be in the store. That is to say, the store will have changed, the memory will have changed. So in fact, what our vec swap needs to do is to return a new store. And this new store will, instead of having a 3 in location 237, it will have a 4 in location 237. And instead of having a 4 in location 238, it will have a 3. That is to say, those two values will be swapped. So this is a test of our new vector swap operation. Let's take it down here and see if it works. Well, of course it won't. In fact, it completely fails because it's not even getting the right type. This thing wanted a mu-vec, not a vector. Or we're now passing a mu-vec, not a vector. So let's say mu-vec. Okay, so that contract now looks right. And what we're now seeing is, oh no, all the other parts of the program that are using vec swap are now going to signal errors. Oh dear, I forgot to start my timer. Okay, we'll just start that now. All the other parts of the program that use this are now going to fail because they're not using the new type of mu-vec. And what we're going to do here is just comment those out because we want to see whether this thing works. And we also need to comment out these tests. Okay, great. We now have a problem because this thing is not returning the right kind of thing. What we want it to return now, as we've observed from the test case, is a store. All right, and so now what we're going to see is, well, this is the old style of thing, and this is not going to work at all. In particular, vec is no longer a vector, it's now a mu-vec, so we need to update all of these operations. In particular, we need some kind of mu-vec ref, and we also need some kind of mu-vec set. All right, and that thing is definitely going to have to get the store. All right, and here's another mu-vec set. Mu-vec set, and that one's also going to need to have the store. All right, well, that's dandy, but unfortunately we haven't written these functions mu-vec ref yet. All right, well, we got to write this. Fortunately, mu-vec ref is easy. We've already seen most of it. Refer to an element of the store, an element of a mu-vec. Define mu-vec ref is going to have to take the mu-vec, mu-vec of type mu-vec, and then also the index, which is a number. And then it's also going to have the store, type store, and it's going to return a number, the result of looking that thing up. Now, fortunately, we already wrote store ref. Okay, so all we need to do here is to just do, well, I think I can get by with that test case here, I hope. Store ref of, what we need to do is to take the address of the mutable vector and add the index. Mu-vec pointer of mu-vec, and we're going to add to that the index. And that should be enough. We hope that works. It will definitely, however, have to be above this test case. Okay, now here's the thing we don't have. We don't have a mu-vec set. Okay, well, that looks pretty plausible. It looks like we're in the same ballpark there. Update an element of a mu-vec. Okay, and instead of store ref, it's now store set of this index and some new value. Yeah, I wouldn't need to pass in the new value. New val is of type number. Let's just put a new line in here so this makes sense. And this guy is now going to return an updated store. Okay, and it's not called mu-vec ref, it's called mu-vec set thing. And apparently we didn't call it store ref, we actually called it fetch from stow and update stow. Sorry about that. This guy is update stow, and this guy is fetch from stow. Okay. Our type checking now fails for what? Mu-vec ref is going to return a number, and that's fine. But we forgot to pass in the store. That won't do it all. Okay. This thing, I think, is now making an incorrect claim about its return type, and so maybe we can correct that. Actually, that's not true. That looks totally reasonable. Where is our type checking problem here? We're still calling vector ref. I can't call vector ref. I now need to call mu-vec ref on that guy and pass it the store. And then we are still not happy. And the reason is what? Fetch from stow. We forgot to pass in the store here. And now we have also probably forgotten to pass in the store here. Yes, that's true. And everything now type checks. This is wonderful. Unfortunately, our test case failed. If I don't sound surprised, it's because I knew it wasn't going to pass. Let's take a look at what happened here. All right, what it said is, what we said rather, was that we expected to get 237, sorry, what we expected to get was, which is first, the actual or the expected value? Instead of being 237 was 3, 237 was 3. I'm sorry, I'm just having a hard time reading this error message. I can tell you exactly what's gone wrong, but let's have a close look at this error message so that you can also tell what's going on. Here's the call, and then here's what we, good. Okay, great. What we expected was this thing here, where 237 was set to 4 and 238 was set to 3. What we see, unfortunately, is that they're both 3. Somehow, one of the changes got lost. To see why that is, let's go back to this definition of vector swap. Okay, so we made 2 changes to this store, one here and one here. This was the one that updated the copy. Yes, that's right. This one set the first one to be the same as the second one. This set the second one to be the same as the old first one. And what we see is the second one seems to have happened, but the first one didn't. And if we take a look a little more carefully, what we'll see is that each of these returns a store, but the problem is that the store that's being returned from this first call is not being used in the second call. What we need to do is make sure this store gets fed into this one. Okay, now we can start to sense a glimmering of the horror that is going to occur when we start converting everything to store passing style. This expression returns a store that needs to be passed as the store to this one. All right, so this begin needs to change. This is no longer going to be a begin, it's going to be a let. We're going to say let store2 be this thing. Okay, so this first thing, this first set returns a new store, store2, that we need to now pass in as the store to the second one. The store is threaded through the computation. The store returned from this first mutation needs to be passed as an argument to the second mutation. Let's try running our test cases again. Our test cases now pass. So vector swap now seems to be working. It takes in a store and it returns a new store. This is a good stopping point. We've successfully converted one of these things to store passing style. All right.